In this definition, we want to explore logically equivalent statements. Two statements are called logically equivalent if and only if they have identical truth values for each possible substitution of statement for their statement variable. So basically, if you have two statements like P and Q, and if they are logically equivalent to each other, it means that if they have the exact same truth values or they have equivalent values, it's denoted by P is equivalent to Q. All you need to do is to form the truth tables for them, and later on for more complicated or more complex statements, we're going to use the equivalent laws to simplify complex statements. Let's take a look at a couple of examples. Our very first one is going to be the De Morgan's laws. Remember basic operations, for example, or and. De Morgan's law says the negation of P and Q must be equivalent to negation of P or negation of Q. It means that you distribute this negation into parentheses and it changes the AND operation as well. So let's take a look at the table. First of all, you have two original statements, PQ. You have not P, not Q. You also have P and Q. You have the negation of P and Q. And finally, you have not P or not Q. So you're going to list all of these and check the combination of true or false values of P and Q. Since you have two statements, 2 to the power 2, you end up with 4 combinations. So you're going to have 4 rows. Let us explore. P can be true, Q can be true. When P is true, not P is false. The negation of true is false. P and Q, true and true, must be true. The negation of true is false. And then if you combine these two together, you get false as well. False or false is false. So far, these two are the same. Let us move on to the second row and combine the next possible combination. True, false. So the negation of true is false. The negation of false is true. And at the same time, if you combine true and false, it's going to be false. The negation of false is true. If you combine these two using or, false or true is true. So again, we have the exact same truth values. Next combination, P can be false, Q can be true. With the same argument, negation of false is true, negation of true is false. If you combine false and true, you get false back. The negation of false is true. And finally, if you combine these two together, you get true back. Luckily for us, these two are the same. And on the last row, the last combination, remember we have 4 combinations. P can be false, Q can be false. The negation of P is the negation of false, which is true. The negation of Q, which is the negation of false, is also true. If you combine false and false, you get false back. The negation of false is true. And finally, if you combine these two, true or true, you get true back. So you have the exact same truth values. What's the meaning of that? Since these two statements always have the same truth values, they are logically equivalent to each other. So we just proved De Morgan's laws using truth table. Another example for you. Determine if the statements are logically equivalent or not. Here we have P or P and Q, and the next statement is P. So you want to know if we distribute or into parentheses or over and, what do we get after that? So it's a distribution of P over P and Q using or. Remind yourself of basic tables. And now we need to form a table listing all of these possible outcomes. So since you have two original statements, you're going to have 2 to the power 2, or 4 combinations, or 4 rows. Let us begin. P can be true, Q can be true. P and Q, true and true is true. P is true, true or true is true. And at the same time, P has the value of true. So both of these are the same, true and true. The next row is a combination of true, false. True and false is false. True or false is true. And at the same time, P is true. They are the same as well. Let us move on to the next combination. False, true. False and true is always false. False or false is also false, and P is false from the beginning. These two are the same. Let us move on to the last row. The combination of false, false. False and false is false. False or false is also false. P is false, so you get the exact same rows. So here, these two rows are the same. These two rows are the same. These two rows are the same. So you get the very first truth values and the second truth values are the same. So you have the exact same truth values. It means that these two statements are equivalent to each other. So please note that in questions, if you see something like this, you can replace it by P. That's the meaning of having equivalent statements. You can simplify this statement and write P instead of it. The next one is a little bit more interesting because you have 3 statements. Here you have P and Q and R, and you have P and Q and R. So please note that we are grouping these differently. Here we group the very first 2 statements. Here we group the second statements. Remind yourself of basic tables. And here, since you have 3 statements, you end up with 8 rows. 2 to the power 3, which is 8 rows. So as we add more statements, P, Q, R, we get more combinations. So we have P, Q, R, the combination of P and Q, the combination of Q and R, the combination of P and Q and R, the combination of P and Q and R. Let us begin. P can be true, Q can be true, R can be true as well. So this is the very first combination. True and true is true, true and true is true, true and true, also true, true and true, also true. So one by one, we explore the idea of how to combine these together. The next combination, you have true, true, or can be false. True and true is true. True and false is false. Now P and Q was true, along with false. False and true is false. The next combination, now P can be true, Q can be false, and R can be true. You continue exploring the combination of these, but the most important part is using different combination, true, 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 false, true, false, true, and then you have true, false, false. So far we created 4 rows, and again, you have P and Q, true and false is false. Then you have Q and R, false and false is false. We're going back to the original and basic tables. The next combination is false, true, true. And as you can see, the values are exactly the same. The next combination, false, true, false. And finally, here we have false, false, true, false. And the last one is going to be false, 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 false. So as you can see, we have 8 different combinations, and it happens that all of these columns have the exact same truth values. So since they have the same truth values, we say that these two are equivalent to each other. So it doesn't matter if you group P and Q first or you group Q and R. So these two going to have the exact same truth values.